Given a set of data from research or survey, and one is required to interpolate certain values, the methods described will project functions of x regardless of the inclination of the data. Learn more numerical solutions to CE problems. In case the values for x would be in an even interval, that would mean like if taking the difference between these intervals, you are going to have a value which would be even, like for example 1.05 less 1 would give us 0.05, and 1.1 less 1.05 would still be 5, and so on until we reach the last part, 1.20 less 1.15 would still be 0.05, then that is said as an even x interval. In this process, there would be a certain group of formulas that we are going to work on, which would be shown in two methods. That would be forward Gregory-Newton interpolation and backward Gregory-Newton interpolation. Let's start off with forward Gregory-Newton method. The general formula is what we could see as shown, where y is equal to the function of x plus p and delta's function. P is taken as x less x naught all over n, where these parameters would mean x is the required function of x naught would be the preceding value of x, and n is the equal interval of x. When do we use forward Gregory-Newton? Let's say that we do have this table. We've got x, which would be 1, 1.05, 1.1, 1.15, and 1.20. Checking if we do have even interval, just like what we solved earlier, it turns out that they are even at 0.05. Next, we are asked to determine the function of 1.07. From our table, this part, or 1.1, with this corresponding f of x, would be the mid value. 1.07 would be taken before the mid value, and thus we are going to use the forward Gregory-Newton method. Let's start computing for our required of f of x with x given as 1.07. Checking on the spot, we would find from the table 1.07 at this location, which is before our mid value. Thus, we are going to use forward Gregory-Newton method. In this method, we are going to start off with the table. This table would be taking the differences, thus its name as difference table. We would start with our x and y from our values on the table, and the others would be differences, which would be denoted by delta for the first level, delta squared for the second level, and so forth. So let's fill up our table. X would be 1.0, 1.05, 1.1, 1.15, and 1.2. Y's would just be the same as from the table, 1.0, 1.25, 7625, 1.531, 1.82, 0875, and 2.128. Our deltas would plainly be differences. Those differences would be such values. So 1.257625 less 1 would give us 0.257625. 1.531 less 1.257625 would be 0.273375. 1.820875 minus 1.531 would be 1.289875. And lastly, 2.128 minus 1.820875 would give us 0.307125. Do the same for the next difference column, and we would have this until we reach 0. 0.273375 less 0.257625 would give us 0.01575. The next would give us 0.0165. And lastly, 0.01725. Continue with the third column difference, and we would have 0.00075 and also 0.00075. Thus, we would end up at the fourth level difference as 0. In this case, we are going to work on our preceding value for the f of x, taking it as 1.05. It says from our formula earlier that x would be from our preceding value. If we take 1.05, this would mean that we are going to trace our values for delta to be plugged into the formula from this point. Thus, the value for delta would turn out as 0.273375, and that's delta. Delta squared would be given as 0.0165, and delta cube is taken as 0.00075. Now we are ready to plug these values into our equation. So let's have our summary. F of 1.07 is our required. F of x, which we are going to use, would be 1.257625, as we are going to use this as our preceding value of x. Thus, we have x is equal to 1.07 and x naught as 1.05. Our n would still be the difference of the intervals of x given as 0.05. Let's proceed with p. Our value for p is taken as x less x naught all over n. And this would be given as 1.07 minus 1.05 all over 0.05, which when computed would give us 0.4. We proceed with our equation. Y is equal to f of x 1.257625. P is taken as 0.4, so plus 0.4. And the delta, which we already traced earlier, is 0.273375. Next, plus 0.4 times p minus 1, or that would be 0.4 minus 1, or negative 0.6, all over 2 factorial, or 2 times 1, times delta squared, which was taken as 0.0165. And lastly, we get plus p of 0.4, p minus 1 as negative 0.6, and p minus 2 as negative 1.6. This would be all over 3 factorial, or that is 3 times 2 times 1. And for our delta cube, we had it as 0.00075. All of these values of delta has been traced earlier from the table. So if we are going to simplify, we have 1.25, 7625. Everything here would still be a plus. So that is plus 0.10935. And observe that for the next term, we have a negative 0.6, making the whole term simplified as minus 0.00198. And the last term would have 2 negatives. Thus, we work with a positive 0.00048. Computing, we get 1.36504.3. Let's check our value. We have f of 1.07 and checking 1.365043 is indeed within our limits for f of x. Now, with the same example where we are going to search for 1.07, how about if instead of using the succeeding value of x, we would work with truly the initial value of x naught, which is the initial value of x in the table. So that would be saying that with this table, what we are going to use would be traced from x is equal to 1 and our values for delta this time would be this set of decimals, having it delta as 0.257625, delta squared taken as 0.1575, and delta cube would be 0.00075. Note that earlier what we use would be these values. However, we are going to work with the values above them. Now let's plug our values. Our x is still 1.07 and x naught this time, taking the real initial value of x from the table, would be 1.0. N is still going to be 0.05, and our f of x would be 1. Take our value for p. Still going to be x less x naught all over n, which would be 1.07 minus 1 all over 0.05, which would be given this time as 1.4. Then let's plug our values. Y is equal to f of x given as 1 plus p of 1.4 times the delta, which we traced earlier as 0.257625, plus another 1.4 for p. P minus 1 would be 0.4 all over 2 factorial, or 2 times 1, and delta squared taken as 0.01575. Then do the same for the third term. So p is 1.4. 1.4 minus 1 is positive 0.4. And 1.4 minus 2 would be negative 0.6. Everything would be divided by 3 factorial, or that's 3 times 2 times 1. And don't forget delta cube given as 0.00075. Simplify terms, so y is equal to 1.0 plus 0.3600675 plus 0.00441, and since we do have a negative 0.6 on the third term, we would have negative or minus 0.4042. Computing, y, or f of x, would turn out as 1.365043. And this is the same value of the interpolated f of 1.07 earlier. Let's proceed to backward Gregory-Newton method. This method would of course have its own parameters and general formula, where the only difference from forward Gregory-Newton method is, in this case, we are going to add our values instead of having them reduced or minus. P would then be taken instead of x naught as the last value of x, or it would be the closest x succeeding the required. N and x would still be the same. In our same data, we are going to determine f of 1.13, and in this case, you would find 1.13 would be after our mid value. Knowing that what we are going to use in order for us to find f of 1.13 would be backward Gregory-Newton method, we are going to have, in this example, 1.13 would be here, use this value for our x sub n. Still, we would have the same table or the difference table that we had earlier, and since we would have to focus on 1.15, the values of nebula that we are going to use would be taken from 1.15, and that would be these values going up. Thus, for the first level nebula, we would have 0.289875 nebula squared is 0.0165, and that of the cube at 0.00075. Let's summarize our given. So x is taken as 1.13, x sub n is considering 1.15, whereby its f of x is taken as this value 1.820875. N would still be taken as 0.05. For P, which is taken as x less x sub n all over n, or that would be 1.13 minus 1.15 all over 0.05. This would give us negative 0.40. Now we are ready to plug all of our values into the long equation. So y is equal to 1.820875 plus p of negative 0.4. So let's just make this minus. And nebula earlier shown as 0.289875. Then consider the next term, where it would start with p, which is negative 0.4, multiplied by p plus 1, or that would give us positive 0.6. This would be all over 2 factorial, or 2 times 1, and nebula squared is taken as 0.0165. The third term would still be started with negative 0.40. P plus 1 would give us positive 0.6, and P plus 2 would be positive 1.6. This would be all over 3 factorial, or 3 times 2 times 1, with nebula cube given as 0.00075. Let's simplify terms. That would be 1.820875 minus 0.11595 minus 0.00198, another minus 0.4048. Thus, we would have our answer for y simplified as 1.702897. Now, just like what we showed earlier, instead of using the succeeding value of x, how about if we are going to check on the real x sub n, or the last value of x? And that would be from 1.2, or the f of x of n, which is 2.128. In this case, we are going to have a different set for the values of nebula. That would be taken from 1.2, which would still be traced going up. So, our first level nebula would then be 0.307125. Nebula squared would be 0.01725. And that of the cube would still be 0.00075. Then let's proceed with the given. Our x would still remain as the required 1.13, but x sub n would be the real last value, which is taken as 1.20. N would still be 0.05, but f of x of the last value is 2.128. Our p would then be solved as x 1.13 minus x sub n, or 1.20. This would be all over 0.05, which will then give us negative 1.4. Then we are ready to place our values into the long equation. Y is equal to f of x, and that would be 2.128 minus plus p, or minus 1.4. Then the nebula was taken as 0.307125 this time, plus the next, or the second term, which would still start with minus 1.4, p plus 1 with p 1 plus negative 1.4, giving us 0.4, which is negative. This would be divided by 2 factorial, or 2 times 1, and nebula squared, which is 0.01725. For the last term, we would still start with minus 1.4. P plus 1 would be negative 0.4. And P plus 2 would then be positive 0.6. This would be all over 3 factorial, or 3 times 2 times 1. And nebula cube as 0.00075. Simplifying all these terms, we have 2.128 minus 0.429975. We have a negative sign there, having it with a minus sign. Thus, we get positive 0.00483. And again, minus of a negative gives us positive 0.4042. So y is still going to come out as 1.702897, the same value as we have earlier.